Well, hello everybody. We're going to take a look at section 7.4 today. It's the first of 2 days where we're starting to look at the properties of logarithms. And so if you take a look at your guiding question today, you'll notice that it says, how does a logarithm of a multiplication or a division work? So we're not taking a look at all of the properties that we will be dealing with today. We're going to look at just these two to begin with. So as we start working forward here, we're going to take a look at kind of how this all develops. So let's say for a moment that we start with this information. Let's say that we have two logarithmic equations. Okay, so one being log base b of some value m, and we're going to set that equal to x. And let's take another one. We'll say log base b, again, we're staying same base here, of n is equal to y. Okay, now we have to assume here that these are both same base. Okay, that's a guarantee. But the value of m and the value of n are two different values. So therefore our output, x and y, are two different values as well. So you'll notice that since these are in logarithmic form, I can convert them to their equivalent exponential form. So let's take and convert both of them. Okay, so if I convert them to an exponential form, again, following that counterclockwise visual that we've been working with before, we can say that b to the x is equal to m. And likewise, we can say b to the y is equal to n. Now, you might be wondering, well, why would I do something like this? Well, consider what would happen if we were to multiply the two expressions together and simplify the exponential side. So in other words, we're going to take a look at it and say, well, let's do b to the x times b to the y. Now, hopefully in doing that, it would make sense that if I'm multiplying the b to the x times the b to the y, that I would also then on the other side of the equation be multiplying m times n. Okay? Now, that would say over here that we could then argue, well, yeah, let's argue this. We could say that this is b to the x plus y is then equal to m times n. Okay, now keeping in mind multiplying like bases, I get to add my exponents. Now, here's kind of the neat thing, is you'll notice that in this case, if I were to take this form now and convert it back to a logarithmic form, again, I get to use that same counterclockwise visual here. I can argue the following, that I'm going back to a logarithm. So notice that when I went from a logarithm to exponential, it's all about the base. So in this case, going back to logarithmic form, I could argue the log base b of now the product of m times n is equal to the complete exponent here. It's the addition of the x plus y. Now, that's kind of interesting because you'll notice that in the beginning of this whole process, you'll notice that x is equal to log base b of m and y is equal to log base b of n. Well, since I know that I have x here and I have y there, let's replace the x with log base b of m and replace the y with log base b of n. What this would allow us to say then is that log base b of this product, now I'm just going to put that product in a parenthesis here just so that I recognize I'm doing the logarithm base b of that product. But you'll notice here what this is telling us. If I replace the x with log base b of m and replace the y with log base b of n, I have what is considered a multiplication rule for logarithms. So this is one of the first two items that we're going to take a look at today, is that if I take the logarithm of a product, it allows me to write it as an addition of the individual logarithms. Notice that they all stay in the same base. So what this is telling us here is that when we look forward then, is that this is what's called our product property or a multiplication property. Okay, so you'll notice that on your slide there, okay, we're up to like slide 4 or slide 5 already here. You're dealing with the log of a product, okay, where they're saying log base b, whatever it is, of m times n. We can write that as an addition of the individual logs. So log base b of m plus log base b of n. Okay, that's our product property. Now, you'll have a quotient property that we could make the same exact argument and get the same type of derivation. So we're going to use logic here. So if the log of a product is an addition of logarithms, think about what the log of a division would be. Okay, now I'm going to take m and divide it by n. So if a log of a product creates an addition of individual logarithms, our logic would hopefully tell us that the log of a division is going to be not an addition of logarithms, but a subtraction of logarithms. All right? And so those are our two properties. We have the product property, and we have the quotient property. All right? And so what we're going to be doing then is we're going to be taking a look at using these to either make simplifications, expansions, condensing, but these properties will actually come into more play when we actually start trying to solve certain equations. Okay? So take a look at example 1. So you'll notice that in this particular case, it's giving us the directions of saying express each as a single logarithm and then simplify it if it's possible. So in part A, they're telling us here, they're giving us log base 6 of 4 plus log base 6 of 9. Now, what we need to recognize here is that I have an addition of two logarithms using the same base. So this would be which property? Yes, it would be the multiplication or the product property. So what we're seeing here is an addition of two individual logarithms, which would allow me to bring them together as one logarithm. So I can say it's the log base 6. Adding the logarithms tells us it's a log of a product. So notice in this case, if I simplify that, I can say that this is now log base 6 of 36, but we should recognize 36 can be written as base 6. So we would then use previous property that we have already seen, log base 6, and 36 being 6 squared, log base b of b to a power is the power itself. Okay? So you'll notice that you've already got a couple of properties that you've learned about. They will still come into play when we start using our product properties and our quotient properties. Okay? So again, it's going to create some sort of a manipulation, most likely, after you've brought the product or the quotient together, which then will allow you to do a little bit more simplification. Okay? So again, notice what we did. We started with an addition of logarithms. So we need to recognize an addition of logarithms with same base can be written as the log of a product. I make the product, manipulate that a little bit to a same base situation, and I can make my simplification. Now, take a look at the second one. So in the second one here, we have log base 5 of 625, and we are adding log base 5 of 25. So in this particular case, now you'll notice that your numbers are getting a little bit bigger, so we might want to involve a little strategy as we work through this. Now again, we should recognize we've got an addition of logarithms here. So again, what do I get to do with an addition of logarithms? Under same base, I can go ahead and combine them as a log of a product. So I'd get to say log base 5 of 625 times 25. Now I know that as you look at this, everybody, if I multiply those together, I'm going to get a massively large number. So instead of multiplying them together, let's look at the 625 and the 25 as separate entities to begin with. Now we should recognize 25. 25, we can write that as 5 to the second power. Well, 625, that would be 5 to the fourth power. 625 is 25 times 25. So notice that if I do this little intermediate work here, and I might want to do that off to the side just so I don't make a lot of mess in my problem. So I might come over here and I might say, okay, 625 I know is going to be 5 to the fourth. 25 is 5 squared. So I'm just multiplying those together. Well, notice that that becomes 5 to the sixth power. All right? So I could rewrite this now using 5 to the sixth power, and I'm just taking log base 5 of 5 to the sixth power, which is then just 6 by that power property that you've seen already. Log base 5 of the 5 to the sixth power is just the 6. Now, let's take it the other way. And well, wait a second. Maybe let me back up here just a second. There are some of you that might look at this and say, hey, wait a second. Maybe I can look at this a little differently. Could I do it this way? Some of you might have looked at this and said, hey, wait a second. If I know that I've got log base 5 of 625, and I know 625 is 5 to the fourth, could I do this? Could I say log base 5 of 5 to the fourth plus log base 5 of 5 squared? Well, that would be mathematically true here. So notice that in this particular case, since I have things I could write in base 5, this would work because log base 5 of 5 to the fourth power is 4. Log base 5 of 5 squared is 2. I still get the 6, but I want to keep something in mind here. We're working with the idea of logarithm of a product becoming an addition of 2 logs, or the addition of 2 logs becoming the product, or dealing with that with the division, okay? Log of division, subtraction of logarithms. Or if we see the subtraction of logarithms, we can write it as a log of a division. Okay, so the intent here, the intent is to make sure that we are implying or using the property here. So even though it's mathematically correct what I did here, we need to keep in mind that the intent of this problem is to look at it from the purpose that I'm adding 2 logarithms, that I can generate that as a log of a product. Okay, so we're going to stay with that intent as we continue through the remainder of our problems here. So when we take a look at part C here, I am not going to simplify individual pieces, even if it's possible. I'm going to use the intent here. So in part C, you'll notice in this one, we have log base 5 of 100, and we're subtracting log base 5 of 4. Now you'll notice in this particular case, I can't make an adjustment individually here. So it does kind of force my hand a little bit, is that I can't write 100 as base 5. I can't write 4 as base 5. So my only option is to recognize the fact that it's a subtraction here, which means that I can write it as the log base 5 of the division 100 over 4. Now you'll notice that in doing that, I can then perform the division 100 over 4. Well, that works out pretty nice, because then it gets us into something that is now workable with base 5. As we saw earlier, 25, we already know, is 5 squared. So that is essentially letting us say here, log base 5 of 5 squared. Log base 5 of 5 squared then will just be 2. All right? So you will see some problems that maybe you could simplify them individually and get a result. But in many of our cases, we need to at least practice the idea. If I have ones that do simplify, I still want to practice the intent here. In a lot of our cases, though, you're not going to develop the base value that you need to work with until you perform either that addition or subtraction, bringing it down to some sort of a multiplication or division. Then what you can change base to will come out. Now, take a look at one more. All right, so in this one, we have log base 7 of 49 minus log base 7 of 7. Okay, so notice in this one again, this is one of those that I potentially could individually simplify here. Okay, so we're going to stay with intent though. So I want you to pause the video. I want you to do this one real quick. Then come back, take a look at your result. In this case, we could rewrite log base 7 of 49 minus log base 7 of 7 as log base 7 of 49 divided by 7. So again, because I'm doing the subtraction of logarithms of same base, I can write it as the log base 7 of the division. Now I'm going to perform the division. So we get to say log base 7 of 49 divided by 7, which is 7. So you'll notice in this particular case, log base 7 of 7, we should recognize that property as 1. Okay. Now, as you're moving forward then with this, that's what you're going to be working with. Now keep in mind, they might have you doing some other things as well, where instead of condensing it like we are here and simplifying, they might take it the other direction. So keep in mind that you might be taking something from the division or multiplication standpoint, and they want you to write it out using the addition or subtraction property. Okay, so from there, everybody, we're going to let that be it for this particular piece. Very short lesson today. Very, very nice in that regard. And so the assignment, again, is on the last slide, so you're set to go. So from there, everybody, have a great day, stay safe, and we'll see you in the live feed. Take care.